In this video, we are going to solve problems on equations of lines in three-dimensional space. In our previous lecture, I took you through how to derive the equations of the different types of equations of a line in 3D. That is, the parametric equations, the vector equation, and the symmetric equation. So let's get into what we have in this video. But before that, if you haven't subscribed to this channel, kindly subscribe and please watch this video to the end. So let's see how to solve this problem. So write down the equations of the line that passes through the point 2, -1, 3 and 1, 4, -3. Write down all three forms of the equations of a line, right? So now let's see. In our previous lecture, I told you that whenever you have or the conditions you need to get the equations of a line in space is that you need either a point and a direction, a point in space and direction, or you need 2 points, right? So in this tutorial, we had 2 points and you have to find the equations of the line that passes through. So let's get straight. To start, let's make this point, let's say point A, giving us 2, -1, 3. Then I have point B giving us 1, 4, -3. Before you start to find the equations of any line, remember to get the direction. So what's the direction vector? So our direction vector is simply equal to the vector AB. Take note, vector AB. If you were given, fine, you use that. But if you're not given and you are given 2 points, always the vector of the 2 points gives us the direction vector. Take note of that. So what's vector AB? So vector AB is simply equal to the OB, position vector OB minus position vector OE. Is that not it? Where this has coordinates 1, 4, -3 minus 2, -1, 3. Is that not it? So at this point, our vector AB, which happens to be the directional vector, is giving us 1 minus 2, which is equal to -1. 4 minus -1, which is equal to 5. Then -3 minus 3, which is equal to -6. Right. So in a vector form, you bring your angle brackets -1, 5, -6. Okay. So now we have our directional vector. So let's start with the vector equation. So vector equation, I told you that is R is equal to R naught, vector R naught plus vector A T. Is that not it? You know our R to be any arbitrary number or arbitrary point in the plane. Is that not it? So our R is simply equal to R naught is now any of the points. You can choose any point because it's just representing a known point. So let's choose A. So we can have vector 2, -1, 3 plus my A giving us 1, -1, 5, -6 multiplying T, and this alone gives me my vector equation. This alone gives me my vector equation. Let's go to the parametric equation. Parametric equation. So the parametric equation is simply giving us, I'll take, so my R is giving us X, Y, Z, which are all unknown. Is that not it? So given this equation, I will derive my parametric from it. So I'm going to have X, Y, Z to be equal to, this one is 2, -1, 3 plus my vector -1, 5, -6 multiplying T. So at this point, you see that my parametric equation is giving us S is equal to 2 minus T, but this is -1 times T. Then I'll have Y is equal to -1 plus 5T. Then the last one, Z will be equal to 3 minus 6T. So this gives us our parametric equations. Then finally, our symmetric equations. Our symmetric equations is giving us, here we are only interested in making T the subject, right? So making T the subject here, I'm going to get what? T is equal to 2 minus X For this side, I'll have t will be equal to y plus 1 over 5. Then here t will be equal to z minus 3 on 6. Sorry, on negative 6. So let me make it this way. So t will be equal to 3 minus z on 6, right? So now my symmetric equation is simply equal to 2 minus x is equal to y plus 1 on 5 is equal to 3 minus z on 6. And that is the three equations we need. Thank you for joining me in this video. Don't forget to like and share.